Well, hello and welcome everybody once again to ICMDA webinars. I'm Dr. Peter Saunders, the Chief Executive of the International Christian Medical and Dental Association. And today we're privileged again to have Professor John Lennox, who's going to be discussing with me the subject of evolution, a theory in crisis, based on his recent book. ICMDA brings together about 60,000 Christian doctors and dentists from over 80 countries around the world. And the way it's going to work today, we're not having a talk, but the whole thing will be discussion and Q&A. Well, the neo-Darwinian theory of biological evolution, the so-called modern synthesis, is still regarded by many as ruling out theism, belief in God. But there are big questions about it, and I can't think of anyone better to address these from a Christian perspective than Professor John Lennox. John is a professor of mathematics at Oxford University and a fellow in mathematics and philosophy of science at Green Templeton College, Oxford. He's also an associate fellow of the Sade Business School, Oxford University, and teaches for the Oxford Strategic Leadership Program. Professor Lennox is particularly interested in the interface of science, philosophy, and theology, and his books include Against the Flow, 7 Days That Divide the World on Genesis 1, Gunning for God on the New Atheism, Stephen Hawking and God, a response to the grand design, God's Undertaker, Has Science Buried God? And Where is God in a Coronavirus World? And 2084. I can really recommend all of those books for a good workout. He's also written another book more recently, which is the subject of today's discussion. A bit more about that later. John has also debated a number of prominent atheists, including Richard Dawkins, Christopher Hitchens, and Peter Singer, and you can access his website at www.johnlennox.org. So, John, it's a real pleasure to have you back on ICMDA webinars today. We're very grateful for you giving the time to this, and we're really looking forward to what you have to say. Now, as we've mentioned, many listeners will be familiar with your book, God's Undertaker, Has Science Buried God?, which came out some years ago. But I think far fewer will be familiar with your more recent book, Cosmic Chemistry, where you build significantly on the arguments from your first book. And I was intrigued to read it recently, and it was on the strength of this that I've asked you to come along today and address questions on the topic evolution, a theory in crisis. And of course, there's much, much more in that book about faith and science than just evolution, but that's what we want to concentrate on today. Now, of course, we're told, aren't we, that the extraordinary biological complexity and diversity we see on planet Earth is the result of a long process of millions of years involving inanimate matter first giving rise to DNA and protein producing organisms, then unicellular organisms giving rise to multicellular organisms, then to invertebrates, and then to vertebrates, reptiles, birds, and mammals. And I want to get into the detail of this with you as much as we can in the time we've got today. But I first want to ask you about the impact of the theory of evolution on Christian belief and the best apologetic approach to use when discussing it. So first of all, but before the theory of evolution came along, most people living in Europe were theists. They believed in God. And one of the strongest arguments for theism was the so-called teleological argument, the argument from design, which the Apostle Paul himself uses in Romans chapter 1. But what evolution did, in effect, was to offer an alternative explanation for biological diversity and complexity that did not require God. In other words, it made atheism intellectually respectable. What impact do you think the theory of evolution has had on Christian belief, John, especially in Europe? And how important is it for Christians to be able to talk about evolution intelligently?
Well, I'm delighted to be with you on ICMDA, and greetings to all of you around the world. The impact of the theory of evolution has been very deep, particularly in Europe. And I still meet it, even in academic circles, as one of the number one reasons for believing in God. People just say it was okay up to the time of Darwin to believe in an intelligently designed universe, but now we've got this explanation in terms of natural processes of the kind that the natural sciences study, so we don't need God anymore. Now, even at the time of Darwin, though, there were people who rapidly rushed in and said, but just a moment, isn't it possible that what he discovered and what was subsequently added to it was God's method of creating the world? So it didn't create worldwide atheism, but it's still, as someone has said, a wonderful engine for generating atheism. The impact is great, and among students particularly and young people, you still find they feel it's the knockdown argument against God.
Yeah. And how important is it for Christians to be able to talk about evolution, particularly Christians from a scientific background? Our audience today, of course, are all dentists and doctors.
I think it's extremely important, though not everyone is a biologist. I'm not a biologist, I'm a mathematician, but I'm encouraged by the fact that from Darwin to Dawkins, people have written to try to convince the thinking public of the truth of this theory. So I approach it at the level of the public understanding of science. And I think it is extremely important that Christians, especially educated Christians, and certainly Christians in the medical and dental fields, know how to find their way and navigate the issues, because it's very easy to get lost in a morass of side argument rather than concentrating on the main issues.
Yeah, absolutely. And the theory of evolution, of course, creates a lot of tension, even between Christians, let alone between Christians and atheists. And the Bible-believing Christians seem to be divided into three main camps. In the UK, I know it's basically a third in each of these. First of all, there are the young earth six-day creationists who take Genesis chapter 1 very literally in terms of 6 24-hour periods. Then there are the old earth theistic evolutionists who accept Darwin's theory, but argue that evolution was a divinely guided process that God used. You've already mentioned that back in the 19th century. And then in between, we've got old earthers who are special creationists. In other words, they argue that God made a number of interventions in history to create different kinds of life. And I'm not going to ask you which category you most closely identify with, but rather I want to ask you about the best way of talking about evolution to atheists who see evolution as a real barrier to faith. Should we be promoting one of these three views, our favorite one, or should we rather just be laying bare the shortfalls of evolutionary theory to show that believing in a creator God is still a plausible position? What's your own apologetic approach addressing this?
Well, it's very kind of you not to ask me to commit myself to one of these three views. I have, of course, written a book on that very topic, and you might be interested to know there's a very new edition of it, 7 Days that Divide the World. But the important point is exactly that. Of course, we should promote a biblical view. And of course, we should lay bare the shortfalls of evolutionary theory. But I would stress at the very beginning that we need to distinguish very carefully between primary and secondary issues. For example, the fact of creation in the beginning God created the heavens and the earth, is vastly more important in representing Christianity to the contemporary atheistic world and postmodern world than when it happened or how it happened. Although both of those questions are interesting. The first one is more interesting to scientists, and the second one is more interesting to theologians. So if we distinguish between those two and remember to be humble, intellectually humble, that, let me put it this way, I believe that Scripture is God-inspired, it is the Word of God, but I'm not claiming to understand all of it. I also am passionate about science, but there are questions of interpretation on both sides, and we need to try to distinguish what is reasonably, evidently fact and what are our deductions from that. And my approach is simply this, that on the precise issue that you've asked me, deducing atheism, as many do, from evolutionary biology depends on the truth of two propositions, which are very different. The first is it philosophically legitimate to deduce a worldview, atheism, from biology, neo-Darwinian evolution? The second thing, does neo-Darwinian evolution actually bear all the weight that people put on it? Now, those are two very different questions. The first one is philosophical and logical. The second one is primarily scientific. And we need to distinguish between them. One of my colleagues at Oxford here, who's just retired, Alistair McGrath, points out that there's a substantial logical gap between Darwinism and atheism. And he adds the rather delightful point, which Dawkins, he says, seems to prefer to bridge by rhetoric rather than evidence. Now, my position on that is that to the extent that guided biological evolution in any sense has occurred, then of course it's certainly compatible with theism because God is behind it. But the issue is, has it occurred and does it bear all the weight that's put on it? And I understand you want me to concentrate on that point.
That's right. And I want to, as much as it's possible in the time we've got, to walk you through the different stages from inanimate matter up to vertebrates and particularly human beings. So let's start right at the beginning. And with the biochemistry, John, we were all taught at school that amino acids, which of course are the building blocks of protein, were produced in a primeval soup where electrical discharges acted on a mixture of water vapor, ammonia, methane, and hydrogen. The Operon theory, I think it is, Miller's experiments. Now, I know you're very skeptical about this on scientific grounds. Why is that?
Well, the important thing here, Peter, is to realize, and I want to emphasize this point, I'm not a professional biologist, though I've studied a great deal of biology. So what I'm going to say is primarily coming from the mouths of people that work in the field. That's extremely important to check out what is actually happening. And before we get into this, we need to distinguish between what's called chemical evolution and biological evolution. That is what happens after life has started. Now, Richard Dawkins has confused this issue for many years because he wrote in his famous book, The Blind Watchmaker, that natural selection accounts for both the existence and variation of all of life. And it took him a very long time to realize that natural selection cannot account for the existence of life, because, of course, natural selection is a biological phenomenon. It depends on life existing in the first place, so it cannot account for it. So we need to distinguish very carefully between those two different kinds of things, which unfortunately are both called evolution, although they're very different processes. Now, to address your question directly, geochemists, first of all, now think that the Earth's early atmosphere did not contain the quantities of ammonia and methane and hydrogen needed to produce the kind of atmosphere that was required by Operan's hypothesis. Secondly, getting amino acid building blocks, which they did, they got some of them, would only be the beginning, because the problem is not so much getting the blocks, although that theory does not produce them. The problem is getting them in the right kind of order. You see, let's take the simple thing first. Proteins are composed of amino acids, and a short protein maybe has 100, most of them are about 300, and they exist in two forms, the L and D forms that are mirror images. And these two forms appear in equal numbers in a prebiotic simulation, so that the probability of getting one or other is a half. But the great majority of proteins contain only the left form. And the probability of getting 100 of L form is a half to the power 100, which is about 1 chance in 10 to the 30. So right at the very start, you're having huge probabilities to face, minuscule probabilities to face just in getting the right size. But then you have to join the amino acids together, and protein demands bonds, the peptide bonds, to be of a certain kind in order that, and this is hugely important, that the protein folds into the right structure in 3 dimensions. Yet only half the bonds in simulations are peptides. So here we go again. The probability of getting 100 like that is 1 in 10 to the 30. So you're now down to 1 in 10 to the 60. So at the very start, before we even begin to discuss the ordering of amino acids, the probabilities are very much against getting this by prebiotic simulations.
Yeah. Now, so let's move from amino acids to proteins then. And in your book, you say that proteins are, and I quote, immensely specialized, intricate constructions of long chains of amino acids in a specific linear order. And of course, as you've also said, it's particular configuration. They've got to fold and bend in the right way to work as enzymes or proteins. And you say a major problem for scientists to explain is the origin of the informational structure of protein. Can you explain what you mean by that and why it is such a problem?
Well, I think the simple way to look at this is to take us immediately to the most famous molecule in the world, the DNA molecule, which consists of 3.4 roughly billion chemical letters in a specific order, looking very much like a piece of computer code. In fact, that's the language that is used. And that determines the sequence of the amino acids. They have to be lined up in precisely that hugely long and hugely complex sequence. And that is the problem that has to be addressed. Now, I love reading physicist Paul Davies. He's usually very graphic. And he says making a protein by simply injecting energy is like exploding a stick of dynamite under a pile of bricks and expecting it to form a house. The point is that you can produce bricks, but making a house requires a plan. It requires information. So that builders can follow that and put the bricks into the right place. And that's a trivial job, compared with getting the amino acids in the right places in this chain. Get a single one in the wrong place, just like if you get a single letter in the wrong place in a computer program, it could become another word, but it's more likely to become complete nonsense. And the problem, for example, there are 20 amino acids, and getting one in a specific site, probability is 1 in 20. So getting 100 in the correct order would be 1 over 20 to the power 100, which is about 1 in 10 to the power 130. And then once you get there, you realize that that kind of simple mathematics concerns only a single protein. But life requires hundreds of thousands of proteins. And it has been calculated that the odds against producing these by chance is more than 1 in 10 to the 40,000. And that's what provoked Sir Fred Hoyle, who was a formidable mathematician, to say that the probability against the spontaneous formation of life was something like the chance of a tornado sweeping through a junkyard and producing a Boeing 747.
Yeah, I mean, that really puts it into context. In terms of those big numbers, John, just remind us what the number of atoms in the universe is.
I think they reckon about 10 to the 80. So these other numbers are just incredibly great. Yeah. Sir Roger Penrose, who's probably one of the greatest living mathematicians, he says the probability of the creator, now he's not a theist, he's an atheist, the creator producing a universe like this one, in which there's a second law of thermodynamics, is around 1 in 10 to the 30. And that means that if you put a 1 and then zeros on every elementary particle in the universe, you couldn't even write the number out. So there's something going on here. And the mathematician in me says, look, there must be something else. And my answer is, this is the evidence of an input of intelligence, because the way we measure it is in terms of information, and information and intelligence are associated in our minds intimately.
Yes, well, and those numbers are astounding. Let's move from proteins to the interaction between proteins and DNA. And we're all familiar with the old riddle: what came first, the chicken or the egg? And you quote Roger Shapiro, expert on DNA chemistry, in your book, as saying that DNA holds the recipe for protein construction, yet that information cannot be retrieved or copied without the assistance of proteins already in the cell. In other words, you need DNA to get proteins, but you need proteins to get DNA. Doesn't this create a problem in explaining how proteins and DNA both came to exist in the first place? And what do scientists say about that?
Well, it creates a vast problem, because the replication of DNA, which is an absolutely mind-boggling process, cannot proceed without the prior existence of a number of other proteins already in the cell. Now, Robert Shapiro, who's a world authority on DNA chemistry, he points out that proteins, though they are built following instructions in the DNA, are large molecules themselves that chemically are very different from DNA. So the question is, which large molecule appeared first? Proteins, the chicken, or DNA, the egg? And what is becoming increasingly clear is that it is the cell, not DNA, and not the proteins, but the total cell that's all important, which leads to the question, the chicken egg question, which is massive. Is the whole thing bottom up, or is it top down? And I attended the quite a few of the systems biology seminars here in Oxford that were led by an absolutely brilliant scientist, Professor Dennis Noble, who's a fellow of the Royal Society. And he points out, he says, look, genes by themselves are dead. It's only in a fertilized egg cell with all the proteins, lipids, and everything else inherited from the mother that the process of reading the genome can get going. At least 100 different proteins are involved in this, without which the genome would express nothing. So he adds, even at the very beginning of a new organism's life, more is happening than is dreamt of in the reductionist bottom-up model. And so what he's doing here is critiquing and criticizing the reductionism that permeates this whole system. That is the idea that everything basically reduces to physics and chemistry. And if you've got the physics and chemistry there, if you like, in the primeval soup, everything else will follow by natural, unguided processes. And they're saying there is no way. The very structure and relationship between DNA and the cell rules that entirely out. So you have to ask a very big question. In fact, there's a very interesting book by one of Brazil's top biologists, who's actually a Christian, a very interesting writer, Marcus Eberlein. And he calls this chicken and egg circumstance causal circularity. And he points out that it's found all over living systems. And he says that there's no way out of circularity without introducing the foresight of a mind, which is a very interesting way of putting it, I think.
Fascinating. I found one of the most interesting chapters in your book. It was all enthralling, but was the one on systems biology right at the end. We'll come back to that. But you point out that the genetic information contained even in the smallest of organisms, viruses or bacteria, is much larger than the information in the laws of physics and chemistry. You say that scientists have failed to give any plausible, yet alone convincing explanation of the origin of that information. And you add that the only source we know of the kind of language type information that we see in a living cell encoded in DNA and RNA is actually mind, not matter. Do you want to unpack that a bit more for us?
Well, as you said, it's not simply I who say it. And think of Francis Crick, who unraveled the DNA molecule. He once said that the origin of life seems almost to be a miracle. So many are the conditions which would have to be satisfied to get it going. And I once met his colleague, James Watson, and I quoted this to Watson. And I said, "What's your take on this?" And he got very angry. And he said, "Well, it happened." And he turned round and walked away. It's very interesting, that it raises such big questions. And I think the short answer to your question, and the only answer to your question, Peter, is we just do not know. The really top people say they don't know. That Francis Collins, for example, who led the Human Genome Project, he was very open about it, and he said, at the present time, we don't know. No current hypothesis comes close to explaining how, in the space of a mere 150 million years, the prebiotic environment gave rise to life. And you mentioned specifically the laws of physics. Well, they're not a good candidate. Hubert Yockey, one of the pioneer writers in information theory, and actually also a Christian, together with Dean Overman, who is also a Christian, said, look, by definition, a law of nature is a short algorithm. Life requires much more information than contained in these laws. And for example, the genetic information in even the smallest living organism is much larger than the information contained in the laws. And they made the interesting point that if we think that the laws of physics and chemistry will explain life's origin, we're looking through the wrong end of the telescope. But the most interesting writer on this, and I really recommend to all of you to watch the Pascal lectures by Professor James Tour, T-O-U-R, of Rice University in Houston. He is regarded as one of the world's top synthetic organic chemists. And here's his verdict. He's done a lot of work on origin of life. And his verdict is, based on what we know of chemistry, life should not exist anywhere in the universe. Life's ubiquity on this planet is utterly bizarre, and the lifelessness found on other planets makes far more chemical sense. And even Paul Davis, with his colleague in Arizona, Sarah Walker, says, look, in our view, an explanation of life's origin is fundamentally incomplete in the absence of, and I regard this as important, in the absence of an account of how the unique causal role played by information in living systems first emerged. We need to explain the origin of both the hardware and software aspects of life, or the job's only half finished. Explaining the chemical substrate of life and claiming it as a solution to life origin is like pointing to silicon and copper as an explanation for the goings-on inside a computer. And I think that absolutely gets it. It's not a question of matter. It's a question of information. And of course, information is not material. It's carried on material. So this is one of the things that leads me to think that the whole philosophy of materialism is doomed because of the discovery within science of information and its function within biology.
Now that analogy with software and hardware is very interesting. And, you know, perhaps the software, if you like, is the DNA code, the program, and the hardware is the structures which it requires to work. And I want to just move from amino acids, DNA and proteins now to the cell. You've already alluded to this, but you quote Michael Denton, geneticist, as saying that the gulf between the non-living world and the living world, he says, represents the most dramatic and fundamental of all the discontinuities of nature. He says that the tiniest, even of bacterial cells, is a veritable micro-miniaturized factory containing thousands of exquisitely designed pieces of intricate molecular machinery made up altogether of 100,000 million atoms, far more complicated than any machine built by man, and absolutely without parallel in the non-living world. And I guess the question there is, what evidence is there that the first cells arose spontaneously as a result of random physical processes, as opposed to being the product of intelligent design, whatever the mechanism?
None that I have ever seen that's convincing. Now, Michael Denton, by the way, gave you your title for this webinar, Evolution, a Theory in Crisis. And I know Michael Denton. He is from your country, I believe, New Zealand. But Michael still thinks that evolution is a theory in crisis as of 2022. So he feels that the evidence is even stronger. And you can add to what you just quoted the staggering fact that each of the approximately 37 trillion cells in the human body performs, each of them, millions of operations each second. Now, to directly go to your question, the major problem is the one we've already covered. It's the language-like structure of DNA that natural processes, and particularly random ones, do not produce language. But if they had, which nobody like Denton believes, you would expect that cells have shown some kind of sequential evolution through past time. But he says there's very little evidence of that. In fact, molecular biology has demonstrated that the basic design of cells is the same in all living systems, essentially. The meaning of the genetic code is virtually identical. The size, structure, and component design of the protein synthetic machinery is practically the same. In other words, he sums up by telling us that no living system can be thought of as being primitive or ancestral with respect to any other system. And here's the clincher, nor is there any, not the slightest, experimental hint of an evolutionary sequence among all the diverse cells on Earth. It just seems that the bewildering complexity. Now, I think I need to say this. We need to be careful with the word complex. The living cell is complex. If I pick up a stone, it's complex. But the difference between the two is that although the stone might be a crystal and exhibit certain symmetry properties, it's still very simple. It doesn't show any of the complexity associated with language. That is a different sort of complexity. It is semantic, and that's what we're dealing with. We're not saying, look, intelligence is demanded by complexity on its own. It's demanded by specified complexity that is linked in with the language, whether it's the language of DNA or it's ordinary language. If I look at the logo on this webinar, ICMDA, I see there 5 letters, and I see the symbol of a cross. And I know immediately from those 5 letters and the symbol that there's intelligence behind that, whatever processes have been involved in producing it. We recognize that from 5 letters plus a cross, let's say 7 strokes or 8. 3.4 billion letters in the right order, and people will just throw their hands up and say, well, that's chance and the laws of nature. It's sheer nonsense. Whenever we see language, we instantly infer not downwards to the laws of physics and chemistry, but upwards to mind.
To mind, yeah. Now, just to change tack again, John, you've talked about the lack of evidence for any sequential change among cells in all living human beings, whether it's human being or all living things, whether it's human beings or viruses at the other end. But let's go more macro now. And Darwin predicted that the fossil record would vindicate his theory of evolution by showing us myriad transitional forms amongst extinct species. And we often hear the argument that the fossil record proves the theory of evolution, the coelacanth fish and so on. What does the fossil record really tell us about the evidence of sequential change among more complex species?
Well, I asked the paleontologists who are the experts on this, and one of them was David Raup in Chicago's Museum of Natural History. And some years ago, he said, we're now about 120 years after Darwin, and we know a lot more about the fossil record. We've got 250,000 fossil species, but the situation hasn't changed much. And now I quote, the record of evolution is still surprisingly jerky, and ironically, we've even fewer examples of evolutionary transition that we had in Darwin's time. And more recently, Stephen Jay Gould, who had no sympathy with the idea of an intelligent God behind the universe, said the extreme rarity of transitional forms in the fossil record persists as the trade secret of paleontology. Now, when I first came across that, I found it amazing. And then I came across his colleague, Niles Eldridge, and he admitted this, which astonished me. He said, we paleontologists have said that the history of life supports the story of gradual adaptive change. In other words, evolution, knowing all the while it does not. And so my brief answer to your question, what do we make of this, is, well, the fact that leading thinkers, such as those I've cited, and there are many others, publicly express concerns about it, shows at the very least that the fossil record doesn't give the support to neo-Darwinism that many people think it does.
Can we move, John, on to the mechanisms of evolution? And I think it was, you quote George Gaylord Simpson famously saying that the product of a mindless and purposeless that human beings are the product of a mindless and purposeless process which did not have us in mind. And of course, the fundamental tenet of evolution at the macro level is that the biological complexity and variation we see in the natural world came about as a result of genetic mutation, natural selection, and genetic drift. Those are the three mechanisms. And of course, very few people who know anything about the science would doubt that evolution exists, at least on a micro scale. Darwin's finches, the peppered moths, the development of antibiotic resistance in bacteria, and so on. But I know you're very skeptical about the evidence for macroevolution as opposed to microevolution. In other words, that gene mutation, natural selection, and genetic drift could produce new body structures, new body plans, and the like. Why your skepticism about that? Because that's really the heart of Darwinian evolution, isn't it? Natural selection.
It is indeed. And what I've discovered with great interest is that skepticism is very much increasing among biologists. For example, Gerd Müller, who's a brilliant theoretical biologist in Vienna, one of the world experts on what's called Evo-Devo, which is a theory that integrates evolutionary theory and developmental biology. He says this. He says that selection has no innovative capacity. It eliminates or maintains what exists. The generative and ordering aspects of morphological evolution, in other words, producing new body plans, etc., are thus absent from evolutionary theory. Now, that's almost a revolutionary notion, because it's going right in the face of the Dawkins type talk about evolution. The late William Provine, he, on the same theme, he says, and he was not a theist, having natural selection select is nifty. Why? Because it excuses the necessity of talking about the actual causation of natural selection. Such talk was excusable for Charles Darwin, but inexcusable for evolutionists. Creationists have discovered our empty natural selection language, and the, quotes, actions, unquotes, of natural selection make huge vulnerable targets. Now, that led somebody as famous as the late Lynn Margulis to say that neo-Darwinism sates intellectual curiosity with abstractions bereft of actual details. So there's this increasing swell, and there's a lot more evidence for this, that natural selection, yes, is responsible for variations. We can observe it, and Darwin did so brilliantly, but it doesn't tell us anything about innovation.
And it's this gap, isn't it, that where is the creative power coming from? I think someone explained it by saying that that evolution may explain the survival of the fittest, but it doesn't explain the arrival of the fittest. How you can get, as I say, new structures, body plans, and so on. out of just these three mechanisms of genetic mutation, natural selection, and genetic drift. It's a problem.
Yeah, that's right. I like that quotation because I think it's precisely right. And I get the strong impression that biologists are coming now to see it. You see, James Shapiro is now one of the world's leading biologists. And here's what he says. The DNA record definitely does not support the slow accumulation of random gradual changes transmitted by restricted patterns of vertical descent. In other words, microevolution building up to macroevolution. He goes on to say this, little evidence fits unequivocally with the theory that evolution occurs through the gradual accumulation of numerous successive slight modifications, as Darwin said. Clear evidence does exist for abrupt events. And it's very interesting to me that one of the neglected figures in the whole history of this, which is Alfred Russel Wallace, who really is and should be much more credited with as being the co-discoverer of the Darwinian, what's called the Darwinian account of evolution. He felt back then that there were limits to what could be accomplished by what they observed, even though they knew, and Darwin knew, absolutely nothing about the gene drift and mutation. They knew absolutely nothing about that at the time. And in much more recent years, mathematician John Maynard Smith was a famous Darwinist, and with one of his colleagues, he says that there is no theoretical reason that would lead us to expect that evolutionary lines would increase in complexity with time. There is also no experimental evidence that this happens. And a lot of experiments have been done that indicate that there do appear to be measurable limits to what microevolution can do. Lenski and his group showed that E. coli bacteria is still E. coli after 60,000 generations of breeding in the laboratory. So there are people who are seriously doing experiments to determine what are the limits. And one of the most famous of biologists said that there appears to be what he called genetic homeostasis. Even living things can only go so far, but innovation, well, obviously it must come from somewhere else.
Fascinating, because that my next question was going to ask you whether research had shown any evidence of a limit to what the mechanisms of microevolution can achieve, essentially gene mutation and natural selection. And you're saying, well, with that example of E. coli, that change happens within very narrow limits.
That's right. And I would recommend, if people want to follow this up, there's a very interesting book called The Edge of Evolution by biochemist Michael Behe. And he refers to malaria. Research on malaria shows very interesting results in this direction and supports that thesis that there is an edge. There are limits. And science can determine them. They're not limits we guess. So we have to go elsewhere because we do know that there are very different kinds of body plans and so on in nature.
Now, John, at heart, you are a mathematician. You're a professor of mathematics. And Richard Dawkins, in his book, The Blind Watchmaker, one of those books that many know more by title than having read, but he uses this illustration of a monkey typing at a typewriter and saying that a monkey typing randomly and granted long life, a very long life, and with unlimited supplies of paper and endless energy could eventually type up one of Shakespeare's sonnets or even a whole book purely by chance. So you've been very critical of this argument. And I wonder if you could tell us why, from your experience of mathematics, make some comments about the mathematics of evolution, and particularly the Dawkins example. I think he talks about the sentence, "Methinks it is like a weasel," from Shakespeare, that he thinks any monkey given enough time and paper and energy would eventually get it.
Well, that's not quite right. And that's what's interesting about it, that even Dawkins, I believe, has totally given up the idea that evolution, in his view, is purely by chance. Because if you concentrate on the first part of your question, monkeys given unlimited time and all this kind of thing, it's very easy to calculate that that's just absurd. Fred Hoyle, again, brilliant mathematician, says that the reason that troops of monkeys thundering away at random on typewriters couldn't produce the works of Shakespeare because the whole observable universe is not big enough to contain the necessary hordes of monkeys. And he says, similarly, the likelihood of the spontaneous formation of life from inanimate matters is 1 to a number with 40,000 noughts after it. And he adds, and I must quote this, it's lovely, "It's big enough to bury Darwin and the whole theory of evolution." There was no primeval soup. This is Fred Hoyle. And if the beginnings of life were not random, they must therefore have been the product of purposeful intelligence. And he summarizes all this by saying, well, as common sense would suggest, the Darwinian theory is correct in the small, but not in the large. Rabbits come from other slightly different rabbits, not from either soup or potatoes. Where they come from in the first place is a problem yet to be solved. Now, your mention of the phrase "methinks it is like a weasel" modifies this whole thing, because realizing that you can't get it by chance, Dawkins now says that evolution involves random elements, but it's not purely random. So his famous attempt to reduce those probabilities to increase the probabilities to manageable terms, he had the idea that the monkeys are typing, but there's a head monkey watching them. And when they get a correct letter, like the first M, the head monkey presses a switch and that thing is held. And of course, you then get the whole phrase quite rapidly. And he said, there you are, that's how it's done. But it's laughable, actually, as many people have pointed out, that the very thing Dawkins hates, that is intelligent input, is precisely what's built into his machine right from the very beginning. There's a target phrase, but he says that evolution has no target. There's a head monkey that recognizes the phrase, recognizes when a monkey has hit a letter, and is able to focus it. It's absolutely absurd, and I have laughed many times. But what worries me, Peter, is that people thought this was a brilliant solution, when really it's a wonderful illustration of subtly introduced intelligent design into the system.
John, we're almost out of time, and I just have one last question for you. I said I'd come back to the whole matter of systems biology, and chapter 19 of your book outlines some of the exciting developments in the burgeoning field of systems biology. And you cite in particular Nobel laureate Barbara McClintock, who demonstrated that an organism could actually modify its own genes, known in complete contradiction of established Darwinist wisdom. Can you tell us a little bit, just briefly, about that and what challenges it's created for the theory of evolution? I think this is coming back to your whole question of, is it bottom up or top down? And you were very much leaning to top down.
Well, it's probably both bottom up and top down, but McClintock is very interesting. And, you know, I'm into my 80th year this year, and the year I was born. And this is important because it tells you how long ago this was noticed. Barbara McClintock made a startling discovery that segments of the maize chromosomes, a plant, could switch places on the genome. This is now called the jumping gene. And this so alarmed the Darwinist world that she was essentially persecuted. She got so opposed by the scientific establishment that in 1953, she felt she had to stop work. But in 1983, she got the Nobel Prize in physiology for the discovery of what are now called mobile genetic elements. Now, the interesting thing is, Peter, you have a namesake who is a very well-known theoretical biologist, Peter Saunders. And Peter Saunders works with a geneticist called Mai Wan Ho. And in 1979, that far back, they published a paper that says that the basic neo-Darwinian theory based on natural selection, random mutation, does not adequately account for evolution. Ho thinks that the modern synthesis has got to be completely replaced. And unfortunately, he says, those people who are very attached to neo-Darwinism won't look at the evidence. Life is achingly beautiful and creative, he adds, once you free yourself from the mind-numbing shackles of neo-Darwinian dogma. Now, that's a hugely strong statement. And McClintock's work has been built on particularly by a colleague at Oxford, the physiologist Dennis Noble, who I mentioned earlier. And he, building on Ho and Saunders, has made groundbreaking advance in further elucidating the epigenetic dimension. That is the thing that goes beyond just the structure of the genome and DNA. This led to the founding of what's called the third way of evolution, and it's worth looking up the website. And the website says the DNA record does not support the assertion that small random mutations are the main source of new and useful variations. We now know that many different processes of variation involve well-regulated cell action on DNA molecules, and there's the top down. And amazingly, in 2016, this work was recognized to the extent that the Royal Society organized a special meeting for 300 scientists, and the title was New Trends in Evolutionary Biology, Biological, Philosophical, and Social Science Perspectives. And Noble has been very outspoken, and I quoted earlier, DNA on its own does absolutely nothing. And he adds, until it's activated by the rest of the system through transcription factors, markers, interactions with protein. So on its own, DNA is not a cause. I think, he says, it's better to describe DNA as a passive database which is used by the organism to enable it to make the proteins that it requires. There's the chicken and the egg with a vengeance. And other workers have added to that. DNA does not contain a blueprint for building the entire cell, but instead contains only small parts of a much larger biological algorithm that may roughly be described as the epigenetic components of an organism. Now, this is very interesting. What we're saying here is that there is a vast level of complexity simply at the level of the genome and the DNA molecule. But on top of that, there is, for example, the fact that the proteins fold. There's information contained at all kinds of different levels. And Dennis Noble has written a book that I enjoyed enormously. It's called The Music of Life, Biology Beyond the Genome. And he says, look, the human genome has roughly 30,000 genes. Imagine it like a huge pipe organ with 30,000 pipes. Now, he says, to think that the genome completely determines the organism is almost as absurd as thinking that the pipes in a large cathedral organ determine what the organist plays. Of course, it was the composer who did that in writing the score, and the organist himself who interprets it. The pipes are his passive instruments until he brings them to life in a pattern that he imposes on them. Just as multicellular organisms use the same genome to generate all the 200 or so different types of cell in their bodies by activating different expression patterns. And I come into this and I want to ask, who is the organ player? And what I believe in concluding this on this point, Peter, is this. All of this development in biology confirms in my mind that this is a word-based world. Hans Christian von Baer, who was very interested in information, coined the phrase, "in the beginning was the bit." I think he got it almost right, because I believe that the right way of looking at this is, in the beginning was the word, the statement at the beginning of the fourth gospel. In the beginning was the word. All things came to be through the word. In other words, the biblical perspective is that the word information is primary and mass energy are derivative. That's exactly the opposite way round from the standard atheistic evolutionism that is being pumped out at a great speed today. But it makes far more sense now scientifically, not just theologically.
Fascinating. And you brought us right back to John 1:1, haven't you? In the beginning was the Word, and the Word was God. I remember Professor E.M. Blakelock at Auckland University, fine evangelical Christian, speaking on this and saying that one of the best translations of logos, the word, was an intelligence expressing itself, an intelligence expressing itself. And of course, we quoted St. Paul earlier, or alluded to Romans 1, where he says that since the creation of the world, God's invisible qualities, namely his eternal power and divine nature, have been clearly seen, being understood from what has been made, so that men are without excuse. And you've put a lot more flesh on those bones today, and whet our appetites about such things as epigenetics and the chicken and the egg, and so on. So thank you so much, John, for your time and your wisdom, being with us today. May God bless you all. Thank you.
Thank you too.